while I'm presenting already the second challenge. So the second challenge is Green Ring Road in the city. To delineate and design bicycle bypass of the city connected to the existing pedestrian and bicycle infrastructure and consistent with the urban greenery. That's the main goal of this challenge. And it's a key element is to plan a bypass that is compatible with the idea of green corridors and to approach the city as an ecosystem. The first team has taken this challenge, and in this challenge we have quite several teams, so it's very important now we stick to time so that we make sure that every team has the same amount of time. The first team, as I was saying, is Northlake, and the solution they are proposing is utilizing telematics probe big data from moving vehicles across the city of Lublin and road characteristics that data from OpenStreetMap in order to build a green road network that will connect 10 major amenities, attractions, universities, parks to the city center based on the level of CO2 emissions and the hazardous events on the different road segments. Northlake, I'm not sure if you're already with us, but
yes,
if
we are.
So,
yes, we are.
If so, the floor is yours. Welcome.
Thank you very much.
Thank you very much. So hello everybody, my name is Servis. I work as a senior data scientist for Bridgestone Mobility Solution.
And myself, I'm Vincent. I'm an economist graduate.
And my name is Andreas. I'm working as a working student at Bridgestone Mobility Solutions as well, and I'm studying data science in the first semester at Uni Leipzig, and together with my colleagues Vincent and Ervis, we have formatted the team Nordlichter.
Now we will present our solution. I will play a video for you. One moment.
Hi, my name is Vincent, and together with my colleagues Ervis and Andreas, we are the team Northlichter. We invite you to hop in and follow along as we show you our vision for the future Green Ring Road network in the city of Lublin. Active mobility is an important cornerstone for sustainable mobility. In fact, studies show that cycling in the city can reduce on average the CO2 emissions of one person by 310 kilograms per year. To tackle this issue and to increase active mobility, we want to change the mobility infrastructure in Lublin from a heavy car-oriented one to one that invites all citizens to opt for active mobility in order to reduce car traffic and CO2 emissions in the city. Furthermore, and important for us is that such an infrastructure connects important amenities with the city center. We are focusing on three main criteria for our solution. First, accessibility. That means suggesting a network that is suitable for all citizens in the city. Second, enjoyability of the network. In other words, preventing citizens to be in contact with a lot of CO2 emissions or facing hazardous events with motorized vehicles. And third, project readiness for an implementation. That means that we are focusing on already existing data and analysis methods that helps to identify the best green road network in the city. In order to assess every street in Lublin regarding hazardous events, CO2 conditions, and characteristics of the road, we are using two main sources. First, telematics data from moving vehicles in the city of Lublin, and second, OpenStreetMaps. My colleague Ervis will explain you in the following how we use these data sources for our analysis.
Hello, the solution we propose is built based on the two important elements. Firstly, we have analyzed the different potential routes and identified the ones with the least amount of CO2 emissions and hazardous events. Then we conducted a statistical analysis and trained some machine learning models to find underlying patterns between road characteristics and hazardous events. To be more precise, we collected telematics data from 1,250 vehicles moving around the city of Lublin in a 1-week period, producing information such as timestamp, geo-coordinates, vehicle types, fuel usage, and many more informations for every 10 seconds of level. Also, we conducted a network analysis using open data from OpenStreetMap, including road length and width, number of lanes, existence of amenities, and many others. Combining all of these pieces together, we built a unique map that includes the level of CO2 emissions, hazardous events, and the current bike infrastructure in the city. Evaluating these informations along with the outputs of the statistical analysis and machine learning models, we built a network that connects 10 major amenities with the city center and has as main goal to approach the city as an ecosystem and provide a healthier and safer life for the citizens of Lublin.
To evaluate our solution, it would be possible to first enroll one of the 10 routes you've seen in the slides before. Here we took, for example, the blue route. In order to do an accurate comparison, we proposed to measure the CO2 emissions on this route before applying the treatment and after the treatment. If there is a significant decrease in CO2 emissions, the city could then think about rolling out more of the routes. To conclude, you can say that the main goal of our pilot analysis was to identify routes with the least amount of CO2 emissions and hazardous events to create a green ring road. To make the results of our solution transparent, we propose to roll out the solution route by route and to measure the improvement which is achieved. A next step would be to make the model more interactive for the main stakeholder of our solution, the city of Lublin. We would like to make it possible for the city to define certain weights to get new routes adapted to their needs. No matter if the municipality wants to focus on creating routes with the shortest distance, the lowest costs, or routes which go through green spaces, our solution should be able to consider all of these requirements. Since the solution is not only addressed to the municipality, but every citizen of Lublin, it would also be important to make sure that they are informed what happens in their city. With a marketing campaign, the changes of the infrastructure could be explained to them, and in addition to that, they could be given incentives for riding the bike or getting rid of their cars. On this last slide, we added an appendix which shows the results of the machine learning analysis, which was conducted to find out which variables have the highest impact on the occurrence of a hazardous event. It can be observed that the length of the road and the changing road speed limit from 30 to 50 have the highest positive correlation with the probability of hazardous events. It is no surprise that a low speed limit of 30 km per hour has a negative correlation with the probability of hazardous events. Last but not least, I would like to introduce you to the people behind our solution: Ervis, Vincent, and me, Andreas.
Ervis, I think you're mute, so we can't hear you.
Yeah, okay, cool, yeah. Thank you. So this is in a nutshell the solution we have built based on analysis on real data from moving vehicles, and are thinking about how the infrastructure of the city of Lublin should be changed in order to make the city more livable and healthier for their citizens.
Okay, thank you so much, Ervis, Andreas, and Vincent. And now time for the jury to ask questions. Members of the jury, any questions for this team taking the challenge too?
Yes, please. Very good job. Congratulations for your presentation. I think that you have really well explained what is your solution. I have just very brief questions, and depends on the answer. Maybe I ask more about this. The final roads that you presented in the map, do they correspond to bike lanes or are also pedestrians? Will be used also for cars, or is it only for the bikes?
Yeah, maybe I can jump in on that. So basically, we started so in this analysis we only focused on car routes. So because we used the data of the moving vehicles to analyze CO2 emissions, but this was also the main goal for now. But in the end, we have, of course, it's very important to include the bike lanes as well, to include, to ask the city, what do they want? That's why we also said, we have to ask the stakeholders, what are the cost restrictions? Do they want to use existing bike lanes? Do they want to use parks? Do they want to integrate that? So for sure, now we can say the goal of this analysis was to analyze streets which are, which can be entered by cars. But for sure, in the second step, if this is an interesting solution for the city, we would then go for the next step and build in the existing bike lanes as well.
But yeah, also to add on top of what Vincent mentioned, the end solution basically is not only to create bicycle lanes, but also we can create as well another pedestrian lane in that roads, if, for example, the width of the lane is sufficient to do so. So it's a collaboration with the municipality of Lublin, how we want to build the infrastructure from now on. Yeah.
And maybe, again, the main point of our analysis is to characterize every street and then analyze on part of the next step would be then how do we design the streets. But the main goal here was really to characterize the streets, which streets are the most suitable ones to integrate in the end solution.
Mm-hmm. Yeah.
I have a question too regarding your model, your machine learning model. Mm-hmm. So you have a pre-existing model that you are adapting to the Lublin city. Is that the way you work?
Yeah, thank you for your question, Elisa. So basically, it's not a pre-existing model. It's the model we have trained in this given time frame of the hackathon. So basically, what we have done is to fetch street segments from OpenStreetMap, and based on a graph theory. So we have every street segment, it goes among 10,000 street segments in the Lublin. And then on top of that, we have the hazardous events, which it goes our target variable, let's say our target feature that we want to predict it. And we added a lot of information, a lot of features to train our machine learning model, such as the width of the road, the length, the number of lanes, the road speed limits, and stuff like that. And we trained a couple of machine learning models, such as random forest, decision trees, extreme gradient boosting machines, in order to identify the best, the model that can predict the hazardous events and can provide the right information on which factors affect the most in the city, the hazardous events, let's say.
Okay, thank you. I think for the short time you have, it's a lot of work. And
yeah, it was.
Congratulations.
Thank you very much. Yeah.
Okay, I don't know if there are more questions in here. If not, I would like to link with what Elisa was saying before. I mean, it's a lot of work, and we are well aware that the teams taking this Citython make a huge effort in a very short time frame to develop things that takes usually a lot of time. So that's really appreciated. And yes, indeed, congratulations.
One quick question, if possible.
Yes,
is it possible? One more quick question.
Yeah,
it's about the you talked about the hazardous events. I don't know if you after your simulations you came up with some kind of reduction in the impact of these hazardous events of the recurrence. Could you give some details on that? So with your proposal, did you analyze how these hazardous events will be reducing in the future? Any kind of estimation?
Yeah, so basically, thank you, Alexander, for your question. So basically, what we analyze here is how these factors, how the road characteristics can affect the hazardous events. And on top of the CO2 emissions, which already we know, based on the telematics data, it produce, prop data every 10 seconds. We make a model combining all of these informations together and propose, let's say, the roads that has the least amount of CO2 and hazardous events. So it's a combination, let's say. So for every of these 10 amenities that we connected to the city center, like universities, museums, etc., we have 3 potential routes. We evaluated every one of the 3 routes based on the machine learning model of predicting hazardous events and the CO2 emissions, and we proposed this network. But of course, this can be expanded, and as you have mentioned, this can be evaluated even more, you know, and identify what causes, let's say, hazardous events. In our training data set, what causes hazardous events the most is, of course, the length of the road. So the bigger the length of a road segment, it makes sense that the more hazardous events will be there. And another characteristic is that when you have a road that there is a road speed limit of, let's say, 50, and then it goes to 30 in the same road segment, this also affects, you know, it can produce a lot of hazardous events by the drivers, because the drivers are you know, are driving in 50 in a road speed with 50, and then they immediately have to harsh braking, you know, to go in a lower, let's say, speed. That's why.
Yeah, okay. No, my question was only because if you want to, let's say, to sell a project to a municipality, then you can came up with some figures like, okay, our proposal would reduce the hazardous events in some percentage, let's say, right? So this, let's say, is good for advertisement in some way. And also, I guess that from your explanation, you already picked up the less hazardous routes, right?
Exactly.
So this is good, but to let's say, be able to say a number, it's always good, even if it's approximate.
Yeah, for sure. We have the predictions. Basically, we have the predictions, we have everything, but you know, we didn't have time to implement in that short time period, because training the machine learning models, doing the statistical analysis, gathering all of this data together was really, you know, a lot of work from us, working on weekends, nights.
Yeah, sure. It's very challenging. No, I completely agree with that. Yeah. Okay, thank you very much.
Thank you very much.
Thanks.
Okay, so Northlake, fingers crossed. We will know who the winners are at 3 p.m. Thanks a lot for your presentation and for being with us today. And we will see each other later today. Thanks.
Thank you very much. Bye-bye.
Thank you. Bye.
Bye-bye. Have a nice day.
Bye-bye.
And now time to move to the second team taking the challenge 2. Their name is Need as Impossible.